Okay, so this video is about finding the angle between a line and a plane. Okay, suppose we are given a plane. Let's say we just look at the plane from the frontal view, and let's say I call this a plane, right? And imagine that we are looking at it from the front, the side, right? And naturally, the plane has a normal vector. Let's just call this n1, right? Yeah, let's call this n1, right? And over here, right, the normal vector. Okay, maybe I just put something. Let's call this n1, alright? And I have another line. I want to find an angle between this line and the plane. So there's a line passing through. Let's just assume that because it can be anywhere, right? The normal vector can be anywhere. So let's assume that we put it at the bottom. And this n1, L1 will just be r equals to a plus lambda m. Okay, where m is the direction vector of the line. Right, so very quickly you can see that the angle between the line and the plane is over here. This theta, right? And since the normal is perpendicular to the plane, we can also assume that this is actually 90 minus theta. Alright? Now, if you just look at these two lines, the normal and this line here, the line we can say is that it also can be represented by the direction vector m1. It can be represented by a direction vector m1. Alright? M1. So to find the angle between two vectors, then it becomes very easy. So now suppose I want to find an angle between these two vectors. Okay, first is m1, next one is n, the normal vector, right? So actually it's like we are finding cos 90 minus theta, right? This will just be n1 dot m1, right, over mod of n1. Am I right? Okay, because we are finding angle between m1 and n1. We're finding this 90 minus theta for a moment. Okay, but if you think about it, right, what is cos 90 minus theta? So based on the secondary 3 go, you know that cos 90 minus theta, this just equals to sin theta, right? So we can actually change this and we say that now, okay, this is just sin theta, which is equals to n1 dot m1. Sorry, m1. They should put this as m1, alright? Over mod of m1. Right, so that's how this formula come about. Okay, and we always assume, okay, for this case, we always assume that our theta is acute, right? So let's take a modulus around this, right? Because we are always finding the acute portion of this answer. Okay, and that's the reason, the formula for angle between a line and a plane. Okay, so to cut a long story short, to find the angle between the line and the plane, alright, if we let theta to denote the angle between the line and the plane, line, which is L will be R equals to A plus lambda M. Lambda is a real number, and the plane P R dot N equals to D. Then the angle between the line and the plane is just given by their direction and normal vector, which is sin theta, equals to the modulus of m dot n, where m is the direction vector of L, the line, and n is the normal vector of the plane. Okay, and then we have our sin theta as follows. Okay, and theta is acute unless otherwise stated.